Right, the second part of this organic chem, we're going to talk about, because by now you realize that chemistry of all the most of the chapters that we learn, we divide them, we like to categorize them. So in this case, we categorize them, but we call it the homologous series. So you have the alkane homologous series, you have the alkene homologous series. You can just call it group or family or whatever you want it, right? But in organic, we use the term homologous series. So you can see that generally with two homologous series you'll be learning for 4N, right? You got the alkane, the ANE, and alkene, the ENE. Later I'll show you example what do I mean. But when we see the last few words, we will know that it belongs to the alkane or alkene. And definitely each of these homologous series will have a general formula. All right. So CnH2n plus 2, CnH2n. Okay, so you can see alkene got double E, and the hydrogen is also two times the carbon, and also has known as unsaturated, means they got a carbon-carbon double bond. So all the double double, right? Okay. Basically, double bond means that you're folding your arms. Okay, double bond. All right. And of course, of the double bond, then this is known as unsaturated. Okay, so you can see that all the homologous series they have a same general formula, right? They have their own functional group, and then which will link to a similar chemical properties. Right, that means the functional group determines how they function chemically, how they react. All right, so you can see the obviously difference. Saturated basically means single carbon-carbon bond. Right, when they are saturated means they're maximum. So the only reaction that they will go through is substitution. Right, this substitution normally with group 17 with your chlorine, and we need UV light. For cracking, is more of big to small. We mentioned just now. Okay, big alkane, crack to smaller size. Right, only alkene can go through this. Whereas for alkene, because they're unsaturated, it's the opposite. That means not maximum yet. All right. Okay. Then they can go through addition. And later part, you must know that they basically will add these three things. Okay, mainly hydrogen, bromine. All right. And even add themselves. All right, we call it polymerization to form plastics. Okay. All right. So these are the things that separate the two homologous series. And of course, okay, even they are same but different. So that means they have definitely different general formula, functional group, and chemical properties. But there's something that's similar. Same thing, all organic go through combustion. Okay, combustion means you need oxygen. So when there's enough oxygen, we call it complete combustion. Okay, when there's lack of oxygen, we call it incomplete. Okay, of course, complete combustion will give us carbon dioxide and steam. If it's incomplete, then you will give a mixture of carbon, which is quite unburnt carbon, the soot, carbon monoxide, which is toxic, all right, and then also steam, a mixture of all this. But normally we will concentrate on the complete. So you can see the difference, right? If I got enough oxygen, sure CO2. When not enough oxygen, there's not the carbon may not even have pair of oxygen or only one oxygen, right? That is the main difference. The type of the amount of oxygen will limit. All right, and then let me just bring you on to look at these two homologous series. So you can see all the alkanes will have the ANE, we know it's alkane already. And the first few words or the first few letters will tell us how many carbon. Okay, so you can remember it's like must eat proper breakfast. That means one carbon, two carbon, three carbon, four carbon. Actually, the first three will be more than enough. Right? So you can see, right, n equal to 1, I sum it into CnH2n plus 2 because this is alkane, I'll get CH4, so on and so forth. Right? And if they say homologous series, you can see it's a difference of CH2, okay, from one after the other, in a sequence. All right? You see, saturated or a single carbon-carbon bond. All right? When it's alkene, you have the E and E. So similarly, right? When we see the E and E, we know we're dealing with alkene. And because alkene must have carbon-carbon double bond, so minimum is two carbon. All right. Okay, so generally same thing, ethene, two carbon, we start in Cn equal to H2n. All right, it is C2H4. So similarly, you can see the same thing, same trends, difference of CH2, all right, from one after another in the same homologous series. All right. So basically, when you say homologous series, again means it's a family of organic compounds that have the same general formula. When you talk about alkane or alkane, all the alkane will have CnH2n plus 2 and similar chemical properties. That means all the alkane will generally go through substitution reaction, right? Okay, because they are saturated. The chemical properties is related to the functional group. Right, and they also can have you can yes you can also say that they are differ by CH2. Right. If they are the same, if they are members of the homologous series, they will differ by CH2 from one another. Right. And of course, one more thing that we mentioned just now is that we look at physical property. This is the trend. Right. As the number of carbon increase, now you know already, right? Alkane, you got a methane, ethane, all these, the melting point, boiling point increase, the viscosity increase, the flammability decrease. This is the same as what how we have understood in the for the fractionation. Just now we mentioned about the crude oil, the fractional distillation of crude oil. Right. And this is the same for both alkane, alkene. Right. So in general, just let me show an example. What do they mean? If you look at alkane, means that technically, as the number of carbon increase, right, from one, two to three, the size become bigger. The intermolecular force of attraction become bigger. Intermolecular force attraction is like a friction, friction between the molecules. So therefore, you need more energy to overcome. All right, and then of course it'll be harder to slide. That's why melting point, boiling point increase, viscosity increase, and of course when the carbon increase, it will become bigger. It's harder to burn. That's why flammability decrease. And this similar explanation will explain for the alkene. Right, it's the same thing. Okay, so we can say this that they will also have a gradual change. They will show a gradual change, in the physical properties. Right, when carbon increase. Okay, this is what you really need to know. The explanation is just good to understand. If not, do not need to worry. Just know that there will be a gradation of physical property as number of carbon increase. All right, that means melting point, boiling point increase, viscosity increase, then flammability is the one that decrease. All right, so that will be the basic understanding of this alkane. Alkene. All right, catch you in the next video to show how we can apply this.